Hi, my name is Michael. I'm working in the JavaFX team and I'm the technical lead for the core components. Today I want to talk a little bit about how you can use JavaFX to write business applications. So usually when you first hear about JavaFX, it's lots about cool graphics and nice animations and doing all of this kind of fancy stuff. But let's face it, most of us don't do this really in their daily life. They may do it for fun, but you want to write business applications for a living. And JavaFX has lots of features that makes that really easy, and that's what I want to talk about today. So first a couple of words about me. I do live in Prague. I was born in Germany, but 5 years ago I moved to Prague. And this is actually really what it looks like in Prague. So it's not Disneyland or anything. This is the Charles Bridge, the Prague Castle here, and the cathedral. So the only exception is usually you have many more tourists running around here. It's really crowded with tourists. I have 2 daughters with whom I spend most of my free time, and I like to cook and to eat. But what's probably most important in this context is how I'm involved with JavaFX. So when I joined Sun Microsystems pretty much 5 years ago, my very first major project was the JavaFX script compiler. So at that time, as many of you probably still remember, JavaFX was not only a library, but it was also a new scripting language that we designed, JavaFX script. And the JavaFX script compiler would now take an application that was written in JavaFX script and compile that to bytecode, so you could run it on any VM. That was my first project at Sun Microsystems. After a while, we figured that JavaFX would make much more sense if it doesn't run only on desktop, but also on mobile devices. But now remember, I'm talking now 4 years ago, right? JavaFX one time. So what we experience right now is kind of a déjà vu, that suddenly it's moving to mobile again. At that time, we created a new project, JavaFX Mobile, and the task was to make JavaFX available on Java ME devices, CLDC phones, small feature phones. And in this project, I was mainly responsible for runtime optimizations or performance optimizations. I think I didn't write any new feature at all during that time, but it was just analyzing the runtime and rewrote large parts to make it faster and actually make it possible to run it on a small phone, because it was originally developed for desktop. So people were just wasting memory and doing things not as efficient as you could have done them, and I had to rewrite them so you could run them on the small phone. 2 years ago, when the large restructure or the reorg came and we changed the whole focus of JavaFX to make it a pure Java library, I became the technical lead for JavaFX core components. The core components are the JavaFX properties, so we extended the Java Bean properties and added some more functionality that you often use on clients, or that you often need on clients. Then the core components contain the binding API. With that you can write all kinds of expressions and bind that to a property, and whenever one of the operands in this expression changes, it gets reevaluated and the property is updated automatically, which helps you to get rid of lots of boilerplate code in your application, because you just define this binding once and then you can forget about it, and you don't have to think about, okay, and at what points do I have to update now or recalculate this expression and set this property again. Also, the core components contain the new collections we added. We have observable collections because it makes a lot of sense on the client specifically that you want to watch a collection and get notifications if it changes. And the last part is the animation API, animation framework, which doesn't really fit to the rest, but since I rewrote it twice during my time in the JavaFX Mobile project, I knew it best, so it kind of just moved with me, and it became also part of the core components. Okay, yeah, I work for Oracle, so I have to show you this. I guess since this is the 3rd day of Java 1, you have seen it a couple of times, and hopefully somebody who actually understands what's written there has explained it to you, so I'll just skip it and consider done. So let's take a look at today's agenda. So about half a year ago, I think, I wrote a little application which is very simple actually, but it already contains some of the features a typical business application would have. So first I'll show you this application and present it to you a little bit, and then I'll talk a little bit more about the process, how I actually implemented this application and how this differs from how you would do it in Swing typically. So I'll talk about the process, and then I'll talk more about the different steps. We'll go into the details of the steps, defining the view, how to do data binding, and also how to do the styling with CSS. Okay, the sample application, it's called JECP, which stands for just another conference planner. So I don't know why everybody's now writing a conference planner nowadays. I guess it just makes sense if you talk at a conference. So I just wrote another one. Here you can see the interface, but actually I want to show you the real thing. So yeah, you have a search field up here. You can search for sessions and for speakers. Click on this so you get a list of results. Maybe didn't really see that. I'll start it new so you can see it. Okay, so you have a search box. You can search for sessions and speakers. Click on it, you get the information, the abstract, etc. So you can click on the speaker, get the other sessions the speaker's doing. Don't be confused, this is actually still the old data from last year's Java 1. I'm sorry about that, I forgot to update it with the current schedule, so don't get confused if you don't know the, or if you haven't heard about those sessions yet, they're from last year. Okay. So how is the application implemented internally? So I use a Java EE application, which was written by Arun Gupta to showcase some of the new features of Java EE 6. And that's running on a Glassfish server here on my notebook. It gets the data from a database, JavaDB in this case. And in addition to providing a web interface, this Java EE application also has a RESTful interface. I'm using that and wrote a client using JavaFX. For communication with the RESTful web service, I'm using Jersey. Yeah, so that's basically it. It's a simple application, but as you can see, it's already representative for how you would do a business application. Okay, now let's take a look at the process. I'll start by describing how the process typically works nowadays when you use Swing, and then I will later explain how this has changed and how this is improved by when you use JavaFX, or how this can be improved when you use JavaFX. So first, the UX designer usually starts to think about the usability. He designs the user interface, the views, maybe specifies some wireframes, and passes that to the developer, who then implements the specification in Java and actually makes it available as a program. And the reason this is done is that a UX designer usually doesn't really know how to code himself. I mean, he has other skills, but he's not a Java coder, so he has to write the information down somehow, pass it to the Java developer, and the developer implements it. The developer adds the business logic, and after a while, hopefully rather sooner than later, a graphical designer is added to the team whose role is or whose job is to make the whole thing look nice. And again, the graphic designer has to specify the design and pass it to the developer, who has to implement it in code. And as we can see already here, this creates rather non-optimal process because we have a huge bottleneck here in the middle. Everybody has to communicate and wait for the developer until he actually implements the changes. And as you can imagine, this is really a frustrating process because the UX designer has to write everything down, pass it to the developer may be in a meeting, and then when he comes back, he starts to implement the changes. When he's done, the UX designer may already have left, so the next day they continue to work on that, and it's really surprising how long it actually takes to create very simple windows with such a process. And the other thing that the other thing what's bad about this process is that the feedback loop for the UX designer and the graphic designer are very, very long, which makes the whole process very efficient as well. As we know from agile development, one of the most important features is one of the most important tasks is to make the feedback loop as small or as short as possible. And by feedback loop, I mean the time between making a change and seeing the result of a change. And you want to try to make that as short as possible. The best is if you can you make the change and you see the result immediately. To give you an example, in coding, when my father, when he was at university, he tried to study programming, and at that time it worked in a way that when he had a task, an assignment to do, he wasn't able to use the computer himself, but he had to write everything on paper, pass that to the IT center, who would implement it in the computer, and the next day usually he got the output, what was most of the time some compiler error, because it's really hard to write code on paper. So it's no wonder that he got very frustrated and quit after half a year. And compare that to nowadays. Nowadays you just type in your code and you see syntax errors immediately. I mean, the IDE shows it pretty much while you type, and you become much faster in developing simple applications, and you can actually write applications which are much more complex than you would ever be able to write when you use this old process of writing stuff down on paper and waiting a day for the result. So for us, for the developers, things have improved dramatically, but those two guys are actually still in this IT stone age. But now I don't want to make Swing bad here. I mean, we shouldn't forget the time when Swing was developed was different. The world was a different place. At that time, when you developed an application, you didn't know about UX designers. I mean, this is a very new concept. I guess most of us have heard for the first time about it in recent years. I don't even know if a job description like a UX designer existed when Swing was developed. So you didn't really worry about that this much. And also on the other side, you didn't use a graphical designer to make your business application appear very well designed. At that time, it just didn't matter for business applications, right? I mean, business applications were supposed to do work. They weren't supposed to make fun. So designers worked on games and things like that, but not on business applications. But now this has changed in recent years. There are a bunch of applications, consumer applications mostly, but also pretty much all new websites are very well designed. They're very simple to use, and people come to expect that from the business applications when they go to work as well. But there's another reason why this is important nowadays. We just figured that very well designed, simple to use web or interfaces, user interfaces, also make people much more productive. So it's not only about making work more pleasant, which is a good reason by itself in my opinion, but it also is really about productivity and making applications more efficient, or make the people who use the applications more efficient. So, sorry. So it's not only about making things more fun, but also to make the people more efficient. So it's really creating business value. So nowadays, if you create a business application, you have to make it look good. It's really important. It's a key feature of applications nowadays. And that means we have now this process when you work with Swing. And JavaFX now can help you to make this process much more efficient. And one way to do it is one feature we added that makes that possible is FXML. So FXML is a standard data format to specify user interfaces for JavaFX. And what makes this a very powerful feature is that you can now exchange the information about user interfaces between different tools. In the past, when you created a user interface, let's say NetBeans, you were not able to use it in another IDEs, in another IDE. You were not able to use it in Eclipse or other tools. So you had to use a specific tool in a project, and you were stuck with that. Now we have this in JavaFX. We have this standard data format, and now you can use the one IDE you really like, and you can actually switch it in a project. If somebody prefers NetBeans, go for it. If you prefer Eclipse, go for it. No problem. You can exchange the information and use the graphical builders which will be built for the IDEs, hopefully. But what makes it what's even more important, what makes it possible, is to create now tools that don't behave like a typical IDE. I guess most of you have seen the scene builder already. That's possible now because we have this data format. And we have a tool where you can put somebody who's non-technical to create the user interface that creates FXML, and you can use that in your Java application, and the Java developer can still use the IDE he wants to use and use that FXML data. On the other side, for the graphical designer, we made it possible to use CSS in an application. And again, this allows the graphical designer to make changes himself, because graphical designers usually don't know how to write Java code. But pretty much all of them know how to write CSS, because in the past, or they have created web interfaces. So with JavaFX, the graphic designer can now change the CSS file himself, load the application with a new style sheet, and then see the updated or the interface with the new design. And so you can see his changes right on the spot. So we made it possible not only to reduce this get rid of the bottleneck. Let me just get back. Not only to get rid of the bottleneck, because I mean the people still have to communicate, but they don't have to wait for the developer all the time. So it's not as blocking anymore. And also we made it possible that the feedback loop for these two guys here, the UX designer and the graphic designer, is now short as well. He gets feedback immediately, and he doesn't have to wait for what his changes look like in the real application. So in all of these components, the Java code, the FXML data, and the CSS style sheets, all of that together now as the JavaFX application. So it's not only Java code, it's FXML, Java, and CSS. So that was the process and how it can be improved when you use JavaFX and use the new features JavaFX allow. So let's take a look at some of the steps here, starting with the view. So for the application, I used the scene builder to create the view. Is anybody here who hasn't seen the scene builder yet? Okay, so I'll just skip that. I'm not going to show it. You have seen it. It's really easy to use. You can just drag and drop stuff. You can, from over here on the screen, you edit the properties over here, and even a non-technical person can use it. As we used to in my former or if you used to say in my former company, it's written for managers and little children. And So now we have this FXML code, this FXML file. Now the question is how we can actually use that in our Java application. And to explain that, I'll make a step back and explain how the JavaFX application in general, or from a high-level view, is set up. So the outer container is a stage, or the outer frame. And the stage is an abstraction, and it depends on the platform you're running on, what this actually becomes. On a desktop system, this is translated into a window. So whenever you use the stage, just think of it as a window. But there are other platforms which may not have, the concept of a window, and there the stage translates into something different. So it's just an abstraction to make the concept of a window cross-platform. Within that stage, you put a scene, and the scene is the real content that we want to show. You can replace scenes and move it around between stages, do all kinds of nice things. And the actual content is declared in a scene graph. So that's a tree, it has a root node, and the leaf nodes down here. These are the elements you want to put on the screen. So it could be text, it could be an image, a shape, a video, and whatnot. And the advantage of this scene graph is it makes it very simple to manipulate the data, because now you can just take this group, for example, and move it around. And all of the children will be moved and rotated, and you can scale it and do all kinds of neat things on the group level. And if you have a good structure of your scene graph, your code becomes very easy. It becomes very easy to manipulate your user interface. Now you may wonder, okay, this is nice if you start from scratch with a new application. So what if I have a Swing application, but I still want to use the new features of JavaFX? There's a way to do that. There's a special class, JFX panel, which is a J component. So you can use it wherever you can use a J component in the application. And in that JFX panel, again, you put a scene with a scene graph, and that way you can use JavaFX components in your Swing application. Okay, so this was just a high-level view on how an application is built in JavaFX. Now we can take a quick look at how FXML looks. So this is not really exactly the code that was generated by the scene builder, but I formatted it and made it more human readable. So, but essentially, this is actually what the scene builder created. And you can already see the structure of the scene graph. You have the root node up here. You have children, different layout containers. And again, children here. You have attributes. For example, the VBox is a layout container that aligns elements in a column. And the spacing defines the space between, defines the space between those elements. So, and if you know the JavaFX API, you can actually get a very good impression of what this FXML code should, or what it describes just by looking at the attribute, which are translated to properties, and the sub-elements, which are also other properties and new nodes in the scene graph. Okay, and to get this data into your application, you just have to use this simple one-liner. There's a class FXML loader with the method load. You pass in the URL to your FXML file. So this can be a file in your file system, but it can also be a file in the web. It doesn't matter. The FXML loader will get it. It will parse the FXML file, generate the scene graph that is defined by that, and give you back the root node of that scene graph. And then you can just take that, pass it to the scene, and you're done. Well, not really, but at least you can see what the UX designer created on screen. What you want to add now is, or what you want as a developer want to do now is add the behavior and access those elements. So how do we do that? We use the concept of controllers for that. So for each FXML file, there's this special attribute that you define for the root node. In our case, it was a split pane. And here's the important attribute, FX controller, and there you pass the full class name of your controller. And when the FXML loader hits this attribute, it will generate an instance of this class and then hook this class up with the scene graph it is generating.
This is all done in runtime?
Sorry?
This is all done in runtime?
This is all done in runtime, yeah. So how do you hook it up? In the FXML, you can define a special attribute ID, for example, search result list. You can specify this in the scene builder. For example, there's a text field where you can add the ID, and then it's put into the FXML code. So you use that in your FXML code, and in your Java code, you have now a field in the controller which has exactly the same name. So here the ID is called search result list, and here the field is called search result list. Then you add this annotation FXML, and that's it, you're done. So when the FXML loader comes to a node or generates a node which has an ID specified, it looks for a field with the same name and then makes sure that this field points to that node. So with that, you can define references to all the important nodes in the scene graph that you want to access from your controller. The other way how you can set things up are event handlers. So JavaFX is heavily based on event handlers. Whenever the user does something, an event gets fired, and you can add event handlers to all nodes to become notified by this. So here I have the text field. Remember the application had the search text field, and whenever you typed something and stopped typing for I think half a second or something, it started to search, started to search for all sessions, for example, that have this string which is in the text field somewhere in the title. So to do this, I added a key typed handler, or you defined a key typed handler, which is called every time you press a key. So in this case, I wanted to make sure every time the key gets pressed in the text field, I'll start a timer, and when the timer is up and the user hasn't typed any key for half a second, I'll start a request with the current value of that text field. So in here you define another ID, you add this little hash, and then put there the name of your event handler on key type. That's how the event is called. And in the Java code, you just have a method with exactly the same name again, and you add the FXML annotation, and that's it. So now every time the user types something here in the text field, this method will be called. So I think you can see it. I blended it out a little bit, but here I'm just starting the timer from scratch. Okay, so and with that you're actually really done. Now you have the data. You can load it and put it on the screen. You can get references to all the important nodes that you want to manipulate later, and you can also attach event handlers to the scene graph that gets generated from the FXML code. So now I want to dive a little bit into layouts because I think they're very important for business applications, and I haven't seen anything this year, any talk about layouts, so I'll go quickly through that. So we have different layout classes. Here we have an HBox. It takes a list of children and then aligns them in a horizontal row. You can change the behavior, you can change the alignment. So here all of the nodes are centered vertically. You can add a padding around if you want to. You can define how large the spacing is between these elements, etc. There's also the VBox, which creates a column. Then we have the border pane. It has these 5 regions, and then you can specify, okay, I want this, for example, this node, which is the status bar, I want to have it at the bottom, and my main screen will go to the center, and then this border pane will make sure that this works. So standard layout container, I think. We have the anchor pane. Here you specify, or here you can anchor the sides of the child nodes to the sides of the container, and you can also define some offset, and then the child nodes will be layouted so they have exactly the distance between their top border, for example, and the top border of that layout container. If you anchor it on both sides, like here, this layout will try to resize your child node if it's possible. I mean, if it's a node that can be resized, it will be resized by this control, by this layout, sorry. Here we have the stack pane. It takes a number of childs and puts them on top of each other. This can be very useful if you want to change the look of a control based on its inner state. So for example, say you want to show an LED, and based on some Boolean variable, it should be on and off. So then you can use a stack pane for that. You have the both images here on top of each other, and based on the state of this Boolean variable, you can just make sure that the proper image is on top. We have the grid pane. It behaves exactly, I would say, as tables in HTML at the time when it was still cool to do layout with HTML tables. In JavaFX, it is still cool. We just renamed it. It's called grid pane and not table pane, but it really gives you the exact same behavior. And for all of these layout skills, you have for all of these layouts, you have many properties to change the behavior. You can specify the alignment of those child nodes. You can specify some padding, etc. Then we have the tile pane that looks at all the children and figures out the maximum width and the maximum height, and then it creates tiles so that it fits, and each child gets one tile, and then it aligns them in this pretty regular looking shape. So you can easily imagine that, using that for something like a file explorer where you have the icons in a regular grid. And the last layout container is the flow pane. That just takes the child nodes and puts them in a row. You define you define a width of that, for example, and then it puts the elements in a row. And when it doesn't, the first element that doesn't fit anymore will be put in the second row, and then it starts to fill that row again until your all of the containers or all of the child elements are set up that way. So I want to be honest with you at this point. Whenever I use the layout API, how can I say that nicely? Well, maybe let's just say the layout API is full of surprises for me. It very often does not really behave in a way that I expected it. And I want to point out two things which gave me lots of troubles in the beginning, just to make sure that you don't run into the same issues again. One is there are a bunch of properties with which you can change how layouts are or how layouts look. But the issue is there are actually three possibilities to change those properties. So some properties, like the layout X, can be set on the child nodes directly. So layout X, with that you can define an additional offset after the child was layouted to be at a certain position. You can add a certain offset to move it. And you do that on the child node directly. It has a property layout X to do that. Other properties are set on the container node. So for the VBox, if you want to set the alignment of all the children, you set that on the VBox directly. Oops, that's not really right. I'll have to fix it. So let's say this is center, for example. So I think that's possible position. So with that, you would say that all the childs which are aligned in a column should be centered in respect to each other. But there's a third approach, Some properties are set like this. You call a static method on the container node, you pass in the child, and then the value of that property. And that's what was kind of confusing for me in the beginning, because I always forgot this last one. What makes it even worse, the way you find a certain property changes depending on which layout pane you're using. So for example, the alignment for the VBox, it is set on the container node directly. For other layout containers, it is set here with this construct. And I mean, I understand why there are three approaches. All of them are necessary, I guess, but it makes things very confusing at times. So this one is usually used for properties that make sense for all layout containers. Like this offset, you can find it no matter which layout container you're actually using. This one here is used for properties that change the behavior of all the children. So here, if you set the alignment, you set it for all the children in this VBox. And this one is used for properties which make only sense for certain layout containers and not for others, but it is used for a single child. So I could see that all three approaches are necessary, but it makes things confusing. So just as a reminder, when you're looking for a certain property and you want to change something, remember there are three approaches, and make sure that you look in the documentation for all of the approaches. Okay, the other thing I'm often having trouble with is the way how the size is defined, how it is used for the child nodes, but also how the size of the container node of the layout pane is specified. I haven't really figured out what the design goal was behind that. So, but what I have found is, even though it's the part of the JavaFX API, the layout API is the part of the JavaFX API I have most trouble with, it is also the part that's that's best documented, in my opinion. So it really makes sense for layouts if you read the documentation thoroughly. I mean, you know, we all kind of read Java docs, but not really. For layout, it really makes sense. Use the documentation, and whenever you find that the layout doesn't behave the way you expected, you will find the answer in the documentation, because it's really very well described what's happening there and how, for example, the size is calculated for certain layouts. Okay, let's take a look at data binding. When we look at this little overview of the architecture, the data comes from the database. It's processed here in the Java EE application, provided as a RESTful web service, and read here by Jersey. I'll not talk about the parts up here. I assume you probably know them better than I do. But what I will look at closer is this part down here. So for the data comes in from Jersey as XML, I think, and to parse that and to deserialize it, I'm using JAX-B. And yeah, this is how, I guess you know this already as well. You define an XML root element that uses this annotation for a class, and then for all the sub-elements in the XML code which match a property in your class, you use that XML element. And what this JAX-B API expects here is a Java bean. What we want to use in a JavaFX application is a JavaFX property. But as you will see, because the JavaFX property extends the concept of a Java bean, it's really easy to mix JAX-B at this point and JavaFX properties. Because we just need to, if you want to do this, we just declare a JavaFX property. So this is an interface defined in the JavaFX runtime. Here we have an implementation of that simple string property, which is the simplest approach to create a property. You pass in two parameters in the constructor. The first one is a reference to the containing bean of this property. So in this case, it's a reference to the speaker, and the second one is the name of the property. So you declare that, and then we just forward the calls to the getter and the setter to the getter and the setter of this object down here. Because it's a string property, it has a getter and setter, and we just forward it. And with that, JaxB is actually happy. So with that, it would already work. But to make it a proper JavaFX property, we have to provide one additional method, and that's this ID property. By convention, it uses the name of the property and this property string, and it just returns a reference to this object down here, so that you can, as a user of this speaker class, you can then use the features that we added to the Java Bean concept, and which are implemented here in this, or which are accessible via this string property. And with that, you're basically done. That's it. I mean, it's really straightforward and easy to use. Now we can get XML data. We use JaxB to parse it and put it into a class which already defines JavaFX properties. Now, if you don't know why you would actually use a JavaFX property instead of a standard Java Bean, here's a little example how you can use it. I'll go through this step by step. So with this expression which declares a binding, we want to show the ID of the currently selected speaker in a label. So this label is a text field that we use. It has a text property, and all the properties in the JavaFX API are JavaFX properties. So it also has this method to get the property object. We then call the bind method on this property, with which we tell the runtime, now we want to bind this property to a certain value. After that, you cannot set this property directly anymore, but it will be updated as soon as this expression here changes. It will automatically be updated. And here we use the bindings class, which provides many factory methods to define bindings easily. The select string takes two parameters. The first is the current speaker. That's another object property here. And then we add a field, or the name of a field. And with that, we create a binding that returns us the ID of the current speaker. So in every time the current speaker changes, or the ID of that current speaker changes, this expression will be updated, and the label will be updated as well. So you don't have to worry about that anymore. You don't have to track, at what, in which situation the current speaker can change, or in which situations the ID of a speaker can change. It's all done for you. You just specify it once and forget about it. So as you can imagine, this reduces your client tremendously. Okay, last topic I want to talk a little bit is styling with CSS. So remember, this is the basic application, or actually I think I show it to you with a real application. So here I have the application. I'm setting, so far it was just using the default style sheet that's provided by the JavaFX runtime. And now I just add this one line of code to read another style sheet, which is defined here. So it's a file on my file system. If I start that now, you can see how the whole, this is a weird design I did here. So, wow. So you can see the font was changed, the colors changed, and even the shapes of the button changed here. But I have more. Let me just change that. So, and you notice I didn't change any Java code at all. I'm just using, loading a different style sheet. And here I have, let's use Java EE maybe for, oops, what was that? Okay, so maybe, oh, Java EE, it's not, I see. I wrote it in one word, right? So now I didn't change any Java code at all. I just loaded a different style sheet, and you can see it looks totally different. I mean, it was inspired by a famous social network, and you can do all of that just in CSS. And last example, which is a little bit more outer space to show you the possibilities. So you can even use that. And again, I didn't change any Java code. Everything is just done using the style sheets. So you can even define very weird looking borders around your elements with the CSS style sheets. Okay. So here you can see what this CSS looks like that we use. And on first sight, you'll notice it looks very much like standard CSS. I mean, there are some differences, that's for sure. But when you know CSS, you understand this pretty much immediately, I think. Let's take a look at this thing here maybe, for example. So here we define an selector which first searches for an element with the ID page tree toolbar. So the ID is a property that every node has. We can set it in our code, and then the designer can use it in the CSS style sheet to look for that specific node in the scene graph. And because we have a scene graph, we also have the hierarchy of the tree, and then we use that as we're familiar with from HTML, for example. Below that page tree toolbar node, we look for all nodes that have this toggle button class. That's another property of all nodes, a style class. And then it looks for all nodes which implement the text class. So you can even specify that. And for all of these text nodes which are belong to a toggle button in this page tree toolbar, we set this effect down here. And you can see down here we describe what happens if this toggle button is selected. Then we change the drop shadow. So it's very familiar, and it works pretty much like it works in HTML. So, okay, here I have the examples in case the application doesn't work. Okay, to wrap it up, as you can see, there are a bunch of tools now available with which you can which you can use to develop JavaFX applications. There's the scene builder, which allows a user experience designer to specify the wireframes, and you can use that directly in your code. You can use NetBeans for development, starting with, I don't know which version. Well, anyway, if you have a current version of NetBeans, JavaFX, the JavaFX plugin is installed by default. For Eclipse, the community is writing a plugin, so you can use JavaFX, which enhances Eclipse for usage with JavaFX. And even if you use IntelliJ, I mean, there's no plugin for that yet, but you can use IntelliJ with JavaFX, because JavaFX now is a pure Java library. There's no reason why you shouldn't do that. And in fact, a lot of developers in the JavaFX team use IntelliJ for development. And Jasper even wrote a small visual tool which you can use to define or change the style sheet for your application. So the tools are there, but what I think is even more important is how the process was or can be optimized now to make the work much more efficient. How this bottleneck here was, you can get rid of this bottleneck, and how you can make the feedback loop much faster, and all people can work on the code base in parallel and see the changes immediately. So that's it from my side. We have 10 minutes left for questions. While we do that, I'll put up this slide with some important links. So up here is my blog. Didn't blog a lot in the last couple of months, but during winter I usually blog more. So I'm writing a lot about JavaFX. This is my Twitter handle, the JavaFX website, where you can download the latest stuff and get all kinds of documentation. If you have questions while you're developing, there's a forum for that, and it's very active. A lot of people from the JavaFX teams read it regularly, and usually, if it's not too hard question, you get answers within hours if you post a question here. If you found a bug, or if you have new ideas how the JavaFX API can be extended, we use Jira for that. There's a public instance that you can use to file issues. And if you want to get involved a little bit more and see what's happening in the future, all API discussions are done on this public alias, so you can just subscribe to that. And all API changes, and I mean even the smallest API change, has to be discussed on this alias. So we're not hiding anything, we're not doing anything secretly. Everything will be discussed on this alias before it is pushed to the repositories. Okay, thank you very much. And now it's time for questions. Yes?
You just mentioned that Jasper wrote a visual tool to edit style sheets.
Yeah.
What's it called, and is it freely available?
It is. I think you can download it from the FX Experience blog, but he wrote it like a year ago. Yeah. So it will be an older blog entry, but it is on the FX Experience blog somewhere. Any other question? Yes, please.
In your example, you used Jersey, I guess, for consuming web services. I'm coming from an HTML space where I'm using a lot of jQuery to do AJAX requests to consume JSON. Is Jersey about the best thing, or are there other things you might recommend for that portion of the business applications that consume web services?
I think there are other solutions. I use Jersey because the developers sit in Prague, and the main developer is a good friend of mine. So when I had a question, he was just across the floor. There are other solutions, but actually I think Jersey is the best solution for doing web service requests. Okay. Any other? Yes.
The data binding example is very simple. It's possible to express doing expressions like if this is selected and that field is valid and other things happen, then I do something.
Yes, it is.
Can expression do binding?
Yeah. I don't know if I have an internet connection here right now. Hopefully, yes. So there's this bindings class that I mentioned, and you can just go through it. You will see there. It will probably take too long now. So there are many methods for defining all kinds of expressions. It's not just adding and multiplying and things like that. There's a ternary expression, so you can say if this is true, take this, else this. There's it's a lot. Just check out those methods and you will see what's possible. Yes, please.
If you're defining all your positions or margins through CSS, why would you also need to do that with code? You've shown how to define your margins and positions on the code. You do that through CSS. Why would you do both? Or is there a conflict there?
It's just possible to do it. I mean, you should probably, just define it for your project what works better for you. I mean, if you do your layouts in, or if you have a designer who wants to do the layouts and define this stuff in CSS, then that's probably the better approach to do. As a Java developer, for me personally, it's easier to use Java code. I can read CSS, but I prefer Java code, so I usually tend to do that. But it doesn't really matter. Just need to define it for your project. There are rules what then happens, but I'm not really sure what will happen right now. I think the Java code will override what's written in the style sheet, because the style sheet is for the whole application, while the Java code is usually just for one element. So I would think this would be the behavior, but I'm not sure yet. I would have to read the documentation about that. Sorry.
The FXML possibly clash with that as well, right?
Yeah. I mean, the FXML is just read during initialization, and after that it's forgotten. So if it's initialized and then you override it in Java code, that's the way to use it. It's really just for initialization. It's not for making the things constant or anything. There was one question in the back. Yeah.
Do you use it with something like JavaFX or something like Java Web Start? The alternate deployment technologies, so you don't have to worry about the whole client.
Yeah, you can use it, but I'm the wrong person to ask about deployment. I'm sorry. I would suggest to go to the booth in the exhibition ground where the JavaFX stuff is, and there are usually people who will be able to answer that. Yes.
For business application, it's very important to reuse components, like customer, the component with many fields, and to reuse it in different scenes, different combinations. What is the best approach to do that? Separate FXML, or what is its best practice to
Yeah.
reusable subcomponents with FXML?
You can embed FXML files in other files. So you can define this reusable component in one FXML file and then reuse it in other files. Actually, I did this for this application. Now I don't remember where are the FXML files. Are probably down here in the view. So I have this expandable abstract, which is a component where you click on this little arrow. Do I have the application open? No. So you click on this little triangle, and then it expands the details. And that's a reusable component because I use it in 2 points. So this one here, right? And that's defined in an FXML file here. And I'm using it in the sessions details, which is a panel, and in the speakers details. And all of that is then used here in the main screen, which describes the whole application. Okay?
Could you open like session details real quick and show us some hash? What you just described?
The FXML file or the... Oops, what's that? Oh, it's opening Scene Builder by default. That's funny. Okay, so you're probably not able to see anything right now, are you? Let me just change the font size. So maybe this is enough. So can you see that? Okay. So I think this is not exactly what was generated by the scene builder, but I changed it to make it readable in case I want to show it to somebody. But this is pretty much what it's looked like. I think the scene builder sets more attributes to the default value and stuff that I moved.
Specifically about the syntax for referring to other XML, the abstract.
Oh, yeah, that's this one here. No. Here. There we are. Include. and then the other FXML file. That's it. Okay, so time's up. Thanks for your attention and enjoy the rest.